So we're going to finish up our last example here. So first off, let's set up the equations because we need one sine, one cosine. So sine, we have y equals a blank for A, sine, blank for B. In parentheses, we have x minus a blank for the phase shift plus a blank for the vertical shift. And I have a few of you in here who missed Wednesday, just at FYI. This one's going to be a bit harder than what I did on Wednesday, so after this example, I'd go back and watch the notes on 1 through 3. It'll make a bit more sense. We'll repeat that for cosine. Y equals a blank for A, cosine a blank for B, x minus a blank for phase shift plus a blank for vertical shift. And then I will show my work under that purple line. So on this example, I want to target reflections. There's a problem on the homework where I ask you that your equations are reflections of sine and cosine. So just showing you how to find those equations on here. Next, we want to mark up our graph a little bit. So let's kind of find where we're at here, find the midline, find the amplitude, kind of find those easy places to start, and then we'll go from there. So our graph on the y-axis bounces between -5 and -3, so the number in the middle is clearly -4. So that's going to be my midline. Which means we have a vertical shift of -4. And I can go ahead and put that in both of my equations. Because vertical shift will affect the entire graph, so it doesn't matter which curve you're looking at. Next, let's work on finding A and B. So once we find the midline, A is pretty easy to identify. From the midline up to our maximum, it's only 1. So our amplitude is 1 here. And reminder, our amplitude does not change. It's the same on the whole graph, up 1, down 1, no matter which curve you're looking at. So A will be the same. I already gave you the heads up that I want reflections here, so I'm going to go ahead and put a negative on both of those ones. Let's pick out our sine curve. Just a visual reminder of what we're looking for. So since I'm targeting reflections this time, I'm going to look for a curve that looks like this. The point starts on the midline, but afterward goes down to a minimum instead of up to a maximum like a regular non-reflected graph. So I have a couple places I can choose from. I can start here at -5 pi over 3. That's a reflected sine. I could start here at 5 pi over 3. That's a reflected sine. And then you could start at 5 pi, but the downside is you can't see a full curve from there, so I'm not going to use that one. All 3 places are going to be good starting points. Just for notes purposes and so my colors don't overlap, I'm going to start at the far left one. So -5 pi over 3 is going to be my starting point for sine. Here's my sine curve. And for emphasis, I'll draw that phase shift vertical line in there. And as you can see, it's through -5 pi over 3. So I can go ahead and write that into my sine equation. This is the main thing that will be different from the sine to the cosine graph, is they will have different phase shifts because they have different starting points. I can't say that I have a cosine curve from this starting point because it's a sine curve of how it starts. So I can't put that same phase shift there. They can't have the same equation. It's not possible. All right, lastly, we just need to find b. Now I want to do just a review of what that looks like on these, because this example is definitely a bit more difficult. The first three problems, how we found the period, you have to find the period to find b. It was easy because we started at 0 and we went out a full curve, and then whatever that right number was, that was our period. So that's really easy to find when you're starting at 0. When you're not starting at 0, which is the case here, you have to do a little bit of math to get there. And we can think about it a few different ways, but there is a straightforward calculation you can do here. So let me show you with the easier example, and it's going to seem unnecessary for the easy example, but it will make sense when I do the harder example. So let me go back to 3 real quick. We did that one the other day. When we found the period, again, that's one curve. Our one curve went from 0 to 4 pi. Left to right, that was the length of distance. So you can clearly see, without doing any math, that the period was 4 pi. But the math behind it is right minus left. Whatever the number was on the right, minus the left will get you your period. So in this case, it would be 4 pi minus 0, which is 4 pi. Again, this is unnecessary to do because you can just visualize it here. But when we don't start at 0, this can be a tad more difficult. So looking at our curve, we go from negative 5 pi over 3 to positive 5 pi over 3. So my period is not 5 pi over 3 because I'm not starting at 0, I'm starting back here. Some of you can do that math in your head, that's great. But if not, this is the calculation you're going to do. So first we need to find the period before we can find b. Our period goes from negative 5 pi over 3 to positive 5 pi over 3. So again, the calculation is right minus left. This will help take care of the negative as well, so if you happen to start in a negative number, it's going to take care of that issue as well. So doing the math, the right number was positive 5 pi over 3. Minus always stays regardless of what comes next. The left number, which was negative 5 pi over 3. And then, of course, when you have two negatives, they're going to make a positive here. So we have 5 pi over 3 plus 5 pi over 3, which is 10 pi over 3. So that's going to be the period. Questions on that? From here, now that we have the period, we can actually find b. So reminder, for b, it's the formula period equals 2 pi over b. And we just found the period. It's 10 pi over 3 equals 2 pi over b. We'll cross multiply to solve that. B times 10 pi, I'm going to write that the other way, 10 pi times b equals 3 times 2 pi, that's 6 pi. And then to get the b by itself, we'll just divide off that 10 pi on both sides. This cancels on the left. B equals, the pi's will cancel as well. And then 6 over 10 reduces to 3 over 5, 3/5. That is our b value. Questions on this work I did down here? Okay. Let's go back up here and fill it in. That was the last piece I needed for my sine equation. So we now know that is 3/5. I'm going to rewrite my final answer, clean it up a little bit. Y equals, the 1 can be dropped, negative sine 3/5 will stay on the outside. And whenever you have this situation where you have that minus minus, please take the extra step and turn that into a plus. Don't just leave it like that. X plus 5 pi over 3. And then I'll just rewrite this as minus 4 at the end. There's my sine equation. Cosine equation. I've already got A and the vertical shift filled in. Those don't change from equation to equation. They're exactly the same. I can also go ahead and fill in B. Because the period, the length of a curve, it's just going to keep repeating. I hope you can see that. So B, regardless if I'm looking at sine or cosine, will be the same the entire graph. So B does not change. The only thing that changes is the phase shift here, and then if I were to do a non-reflected, that could also change, but I'm doing reflections here. Now we need to figure out a starting point for this cosine graph. Again, it cannot be the one I already used. That's a sine curve. They can't have the same equation. So we have to find one. Visually, what we're looking for, the normal cosine graph is an upwards U, so we're going to look for something upside down. So instead of looking for a max to start at, we're going to find a min to start at. You have a couple options here. One of them I already covered in green, so I'm not going to use. But this other curve that starts at 5 pi over 2 is a very nice reflected cosine. So this is what I'm going to start with. In that case, one full curve will go from minimum to minimum. Make sure you finish the curve. And then we draw my phase shift line. So for the orange curve, the cosine curve, my phase shift is 5 pi over 2. So we have sine over here, and then this was my cosine curve. Lastly, I just need to fill that in the equation. So this is positive 5 pi over 2. It's going to go in here. And honestly, there's nothing wrong with this equation. I will rewrite it just to clean it up a tad bit, but this would be fine if you left this as your answer. Y equals negative, I'll drop the 1, cosine of 3/5 times x minus 5 pi over 2. And again, just rewrite that as a minus 4 at the end. One thing I hope you can see from this is once I put together the first equation, finding more equations after that is very easy because very little is going to change about the equation, except for if I use a different function, the phase shift and possibly the reflection. A, B, and vertical shift will not change from equation to equation. So most of the work is just finding the first equation. Bless you.